Back to another video, guys. We continue finding average speed. Before I show you how to work out using theoretical basis, how to derive the formula for the average speed. Make sure you understand that this is basically weighted average over time periods or in time, all values for each partial intervals for the speed. So basically you have the formula for 3 intervals, and this is the general formula using sigma notation. So it definitely looks like the weighted average over the time. So, and I also noticed that it's not the same as arithmetic mean. It's quite a different concept. And today I'll show you that using or during solution for the problem 1, that arithmetic mean and weighted average, that will be different for this problem. In one particular case, they can be coincide when you have different time intervals for given time periods. Okay, so let's have a look at the problem 1. Pause the video, try to do by your own, and let's have a look at more explanations. And let's have a look just at the picture that I prepared for you guys. So for example, that's the starting point for the car, and let it be point A or town A according to the problem conditions, and B is going to be the final point. Let's assume that the car is not moving at the circle path as shown here, but it works as the straight line path over there from A to B, straight line segments. So you have the first half, okay? So what do you have? The first half of the travel distance along this road, car was moving with a speed of 50 miles. So that means we can set up the first interval, let mark as the yellow one from here to here. It's going to be the half of the distance. In that case, we can mark as d over 2. That's definitely half of the distance. If the whole distance, d, is simply the distance between two towns, A and B. So that's why the first half of the distance, it travels with a speed of 50 miles per hour. So let's mark as V1 and mark as 50. So that's going to be 50 miles per hour. All right, so definitely it requires time T1. And make sure you always can work out any variable or any unknown from the equation. Distance equals speed over speed times time. So that's why V times time. That's the base formula here. All right, so what about the second interval? On the half of the rest time, so that's the keywords, not of the rest distance, not the half of the distance, but of the rest time left. The car was moving with a speed of 25 due to the speed limits, and last part of the distance left to town B, the driver was driving the car with a speed of 30 miles per hour. Okay, so how we can mark that part? So definitely, because to the point C, for example, that's some entering point C, it covered d over 2. For the second part, it's definitely d over 2 left. That's fair enough. Here's d over 2. But we have different time intervals within the speed was different as well. So let's set up some point, and let's say as point D, where the car was traveling with the speed V2, which is simply 25 miles per hour. Okay, and the next part, it was traveling with the speed V3, 30 miles per hour. Okay, the total time taken, we mark as T, let's say 2-3, because it comprised 2 intervals. So that's the total time of traveling. So basically, for this time, T 2-3, it covered distance d over 2 with some average speed. So in this case, the average speed is V2 and V3. What we're gonna do, because by definition the average speed is distance over time So we can express also through as the weighted average. So we just simply going to use that formula, but for two intervals. Let's have a look how it works. So we have V2 and we have V3. Because we are said in the conditions half of the rest time, so that means for interval D from C to D, it takes time 2/3/2, half of the rest time, and for interval from D to point B, it takes again time 2/3/2. Times are the same. So that's why we can write the expression for the average speed. So that's why we can set up here as average speed on the interval from 2, 3, okay? And this average speed, 2, 3, it's simply time weighted average taken at the time. So that means we taken V2 multiplied by the time 2/3/2 because it takes half. We add V3 time 2/3/2 again, and we divide by the total time, which is simply time 2/3. Okay, if we simplify that, we can establish that the average speed on the interval from C to B, or in other words 2/3, we'll get the following expression. So V2 and V3, we add them up, while time will be cancelled. So that means it's going to be the arithmetic mean, and that case, only in that case, due to equivalent time intervals, only because of that. But generally, you see, I start from the formula for the weighted average. So that's why average speed 2/3 is V2 plus V3/2. If you like, you can calculate interim values. So for example, we can establish that for first distance, time required T1 is distance over the speed, so that means it's d/2 divided by V1, which is simply d/2 times 50. In this case, it's 100. Okay, and the second time intervals, T2/3, from that formula, it's simply d/2 over V average on the interval 2/3. And this V average we can calculate right now. So V average 2/3 is simply we add in V2 and V3, we'll get 25 and 30. So 25 plus 30/2. And finally, we can get that weighted average is going to be distance over just the sum, right? Because 2 and 2 will be cancelled. Or if you want, you can use your calculator. It's going to be 55. So that's the ratio d/55. So we have, in first case, T1 d/100 and T2/3 as d/55. Let's just rewrite that, or just simply let's try to copy that. So here we just simply insert, let me see. Yeah, we can do that. So that's what we have right now. And the total time for the whole distance, let's move back for a while, from A to B, the total time from point A to B, you can express as just algebraic sum T1 and T2/3. So that's on the first interval from A to C, and that's from C to B finally. Okay, let's have a look at the picture from A to C and from C to B. So right now, what's left is just to plug the values. So TAB, the total time, so that's the total time, is going to be equal to d over 100 plus d over 55. What we're going to do, why we actually express t on the whole distance from A to B? Because right now, that will allow us to calculate average speed on the whole interval from A to B, because we need to find the average speed on the whole way from A to B. So just by definition is the total distance over time from A to B. Okay, so you need to rearrange this expression in order to get the total distance over t over time on the interval AB. And if you express that, if you like, you can add them up and you'll get 155 d over 55 times 100, and that's going to be an equivalent TAB. If you like, you can cancel the fraction, but you can leave as it is. So D over TAB is simply 55 times 100 and divided by 155. If you calculate that, let's just check the answer. What's the speed? What's the average speed you'll have? So 5500 over 155, and you'll get around 35.48. Okay, so that's the average speed, and this is going to be the final answer. So the average speed on that interval on the whole way from A to B is 35.48 miles per hour. Okay, so that's the final expression for the speeds. If you want to compare, what if we just take the arithmetic mean? Let's have a look. That definitely will get different answer. Let's just check. It only will coincide with your answer, that like the same way that I showed you here. Only in the case if time intervals distributed would be equivalent to each other. In that case, you'll have coincidence, or probably different, different values for the speed, so that by chance or accidentally you'll have the same equivalent to arithmetic mean. But let's do that quick. So B1, B2, B3. So this is the wrong way, and definitely like highlight that so that you don't repeat, but this is just a quick check. So if you calculate that, so you add 50 to 25 and 30 to 55 and divide by 3, you'll get 35. Okay, you see the difference. So this using arithmetic mean, and that means it's not correct. So it's not the average speed as the true value. It's not the average speed. So make sure you understand, and that means this is the wrong way. So the final answer should be 35.48. So that's why the right average speed should be 35.48 miles per hour. You feel the difference now, and I hope you understand the way. So I consider this problem as sort of challenging for A-level stuff, for IB, if you're on O level or just GCC extended, so you're doing physics, for example. That definitely should be really hard for you or really challenging, but here is the solution, and I hope you understand the general approach that I'll show you before and that we use here. If you like this video, please like, rate, and subscribe if you're new here, and we just keep doing that and we keep going. All right, that was Daniel Dallas. See you next time.